Hello, how's everyone doing? We're going to go through the radicals and complex numbers review sheet. We're going to go through the even problems so you can check them over. If you have any questions on them, we'll be able to go through them in class tomorrow so that you can get any questions answered that you have. So we're going to start with number 2 here. Going through this very quickly just because they're pretty easy. You have the square root of 96. You want to break this down into two separate square roots, one that's perfect, one that's not so perfect. So 96 can be broken down into the square root of 16 and the square root of 6. 16 is a perfect square, so that will give us 4 square root of 6. If you did it a different way and divided by 4 and got a different number, that'd be fine, but you would just have to make sure that you don't have any perfect squares under the square root. So there's our answer. Looking at number 4, we have 150 r squared under the radical sign. Again, we want to break this down into two separate square roots, one perfect square and one not so perfect square. Well, 150 has 25 that can go into it, and it has a 6. 25 times 6 gives us 150. That r squared is in fact a perfect square, so we can put it on this side. And now we want to simplify a little bit. The square root of 25 is 5. The square root of r squared is r. And then we leave our square root of 6 on the end there. And that is our answer. There's no more perfect squares under the radical sign. Number 6. Getting a little tougher, got some more variables there. But we still want to break it down into a perfect square and a not so perfect square. So 320 can be divided by 64, and it gives you 5. 320 is 64 times 5. That y squared is a perfect square, but the x is not. So we put the y squared over here. We put the x in the not so perfect squares. When we start simplifying, the square root of 64 is 8. The square root of y squared is y. And then we leave our radical 5x on the end because we can't do anything with it. There's no perfect squares in there. So you end up with 8y radical 5x. The last one in that section is number 8. It's the cube root of 16x to the 6. Now you have to pay attention. We're dealing with a cube root here. So you need to figure out a perfect cube that goes into 16 and a perfect cube that goes into x to the 6th. Well, the cube root of 8 is a perfect cube, and that leaves us with a cube root of 2. X to the 6 is a perfect cube because 6 can be divided by 3, so we leave x to the 6 under our perfect side. And then we simplify. The cube root of 8 is 2. The cube root of x to the 6th is x squared. And then we leave the cube root of 2 on the end. So it looks a little complicated still, but our radical there is much, much simpler. The next section, the directions say add or subtract. So we're looking at number 10. We have radical 5 plus radical 5. Well, this is very similar to doing x plus x, which would give us 2x. Same idea here. We have 1 radical 5 plus 1 radical 5, which gives us 2 radical 5. That's simple. Number 12 is 2 radical 5 minus radical 5. Now, don't make the mistake of saying that you're just taking the radical 5s away. That is not true. What you want to do here instead is put your 1 in. So we have 2 radical 5 minus 1 radical 5, which leaves us with 1 radical 5. Or if you don't want to write that one, you can just have the square root of 5 there. Either one of those work. 14, getting a little more complicated. We have to do a little simplifying here. So we want to take that radical 45 and break it down. So we're going to have our 2 out in front. 45 can be broken down into 9 times 5, square root of both of those, and then bring down your second part, plus 2 square root of 5. As we continue simplifying, square root of 9 turns into 3, so we have 2 times 3 radical 5 plus 2 radical 5. That gives us a 6 square root of 5 plus 2 square root of 5, which is 8 square root of 5. 16, even more complicated now, and there is a trick I'll show you at the end for this one. But if we want to break these down, we'll break 54 down into 9 and 6, square root of each, with our 2 out in front, minus 2. 45 can be broken down into square root of 9 and square root of 5, minus 2, and 54, I'm getting close to the edge here, is square root of 9, square root of 6. So just keep working through. We have 2 times 3, square root of 6, minus 2 times 3, square root of 5, minus 2 times 3, square root of 6. So that ends up as 6 square root of 6, minus 6 square root of 5, minus 6 square root of 6. You should notice right away that 6 square root of 6 minus 6 square root of 6 will cancel out, and you'll end up with just a negative 6 square root of 5 as your final answer. And if you're paying close attention up at the top there, you would notice right away that you have a 2 radical 54 minus 2 radical 54, which would cancel out and just leave you with your center part here, which you could simplify. That would have made it a little easier, but extra practice is always a good thing. So, moving on to number 18, which is going into the next section. The directions simply say multiply. So when you're multiplying two radicals, please remember you multiply what's outside. So in this case, we just have ones. It doesn't matter. And then you multiply what's inside. So 10 times 2. So we're going to have the square root of 20. And then we want to break that down. Well, square root of 20 can be broken into square root of 4 and square root of 5, which leaves us with 2 radical 5. Next one is a little more complicated. Again, you want to multiply the outsides first, so 5 times negative 4, and that will give you a negative 20. And then you want to multiply the insides, 3 times 15, so that leaves you with a square root of 45. I'm going to go back to using just one color here. So we have negative 20, and then 45 can be broken down into square root of 9, square root of 5. So we're going to have negative 20 times 3, square root of 5, or negative 60, square root of 5. Number 22, again, getting a little more complicated. We need to distribute here. So we're going to distribute that radical 15 to both of them. We're going to end up with 3 radical 15 plus, there's nothing to multiply here on the outside, so we just multiply the insides, and radical 5 times 5 is going to be 75. Sorry, radical 5 times 15 is radical 75. So we can break that down. 25 goes in there with a radical 3. So we'll have 3 radical 15 plus square root of 25 square root of 3. That gives us 3 square root of 15 plus 5 square root of 3. And I know you're thinking that 15, well, 3 goes into that, but there's no perfect square that goes into it, so we can't simplify any further. The one thing I would suggest you do is switch it so that they're in numerical order. So it'll be 5 square root of 3 plus 3 square root of 15, just so that the 3 is first and the 15 is second. But if you don't do that, this is a perfectly fine answer too. This is just a little bit better. 24. This is our first foiling problem. We're going to have to take the firsts, the outers, the inners, and the lasts. So multiplying the firsts, we'll end up with the square root of 9. Multiplying the outers, we'll have minus 4 square root of 3. Multiplying the inners, we'll have plus 4 square root of 3. And multiplying the lasts, we'll end up with a minus 16. You should be able to see very quickly that the inners and outers are going to cancel here. And we'll be left with just 3, because the square root of 9 turns into 3, minus 16. Well, 3 minus 16 is negative 13, which is our final answer there. 26, another foiling problem. So we're going to want to take, again, the firsts, outers, inners, and lasts. So 5 times negative 5 is negative 25. 5 times 2 radical 3 is positive 10 radical 3. Negative 4 radical 3 times negative 5 is plus 20 radical 3. And negative 4 radical 3 times positive 2 radical 3 is going to give us a minus 8 radical 9. So we're going to simplify down a little bit here. We're still going to have our negative 25. Our outers and inners here can go together and give us a plus 30 radical 3. And on the end, we're going to have minus 8. The square root of 9 is 3. That's where we got our 3 from. So we have negative 25 plus 30 radical 3 minus 8 times 3 is 24. So once again, you should be able to see that minus 25 and minus 24 will go together, and we'll have negative 49 plus 30 square root of 3 as our final answer. 28 is going into our next section, which is rationalizing the denominator. When you have a monomial in the bottom, you just have to multiply by whatever the square root part is, or whatever the radical part is. So in this case, it's radical 5. So we're just going to multiply the top by radical 5, and we're going to multiply the bottom by radical 5. And the reason we do that is because there's only a monomial downstairs there. So we're going to end up with a 6. Radical 3 times radical 5 is radical 15. Over 2, radical 5 times radical 5 is radical 25. So as we break it down a little further, our 6 and our 2 can cancel down so that we have a 3 and a 1. And our square root of 25 will actually just turn into 5 because the square root of 25 is 5. So our final answer here should be 3 square root of 15 over 1 times 5 is just 5. Okay, that doesn't really look much simpler, but you don't have any square roots in the bottom, so that's why we rationalize the denominator, to get the square root or any other radical out of the bottom. 30, very similar to the last one. Again, we have to rationalize the denominator, so we're going to multiply by the square root of 13 on the top and the square root of 13 on the bottom. On the top here, we have to distribute a little bit. It's a little backwards, but that's okay. So we're going to have negative 9 square root of 13 minus square root of 26. On the bottom here, square root of 13 times square root of 13 is a square root of 169. So if we simplify one step further, we're going to have 9 square root of 13 minus square root of 26, because there's no perfect squares that go into that, over 13. Now the 9 and the 13 can't simplify. We have only a 1 on the next part of the 13. That definitely can't simplify. And there's no other perfect squares that go into it. So it looks complicated, but that ends up being your final answer. The last problem in this section is another rationalizing the denominator problem. But this one has a binomial on the bottom. It's got that plus sign down here. So that means we need to multiply by what's called the conjugate. The conjugate is the exact same number, so 7 and 7 radical 3. But instead of having that plus, now we're going to change it to a minus. So 7 minus 7 square root of 3 on the top and on the bottom. This is going to be a crazy foiling problem. So we're going to take our firsts, our outers, our inners. I better move that over a little bit. Our firsts, our outers, our inners, and our lasts. So on the top, I'll use blue for the top. 7 times 5 is 35. 5 times negative 7 radical 3 is negative 35 radical 3. Negative 9 radical 2 times 7 is negative 63 radical 2, and negative 9 times negative 7 radical 3, negative 9 radical 2 times negative 7 radical 3 is negative 63 radical 6. On the bottom, we have to FOIL also. We'll use purple. 7 times 7 is 49. 7 times negative 7 radical 3 is negative 49 radical 3. Positive 7 radical 3 times 7 is plus 49 radical 3. And 7 radical 3 times negative 7 radical 3 is negative 49 radical 9. Now we got a lot of simplifying to do. The top, there are no like terms, so you cannot simplify a single thing. It ends up staying as 35 minus 35 radical 3 minus 63 radical 2 minus 63 radical 6. There's nothing you can simplify there. I know it sucks, but that's the way it is. On the bottom, your inners and outers cancel. We know that the square root of 9 is 3, so this back part ends up being negative 49 times 3, which is 441. So we're on the bottom just going to have 49 minus 441. Running low on space here. So we're going to have 35 minus 35 radical 3 minus 63 radical 2 minus 63 radical 6 all over 392. Because 49 minus 441 gives us that 392. If you got to that point, you're doing pretty good. There is one other step you can do though. If you notice, 35, 35, 63, 63, and then on the bottom here, 392, those can all be divided by 7. So, I'm going to bring us back over here for our best answer, which would end up being 5 minus 5 radical 3 plus 9 radical 2 plus 9 radical 6 all over 56. And I know that was a tough problem. It was a long foiling problem. Not much canceled out, but that ends up being your final answer. 34. Getting a little more complicated. We want to solve some equations now. If you remember, you want to get the square root all by itself. So looking at this, the square root is all by itself. We want to square both sides. Well, when you square a square root, they cancel out, and you're left with just x over 9 equals. When you square the other side, 9 squared is 81. This side is a division problem, so we want to multiply both sides by 9. These 9s will cancel, we'll be left with just x. 81 times 9 is 729. Second one, another radical equation. We want to start making sure the radical is all by itself, which in this case it is, and then we're going to square both sides. So again, when you square a square root, they cancel out, and you just have negative 3 minus 13m equals 6 squared is 36. Down to a two-step equation. Add 3 to both sides. So we have negative 13m equals 39. Do a little divisal. Divide by negative 13. And you'll end up with m equals negative 3. I'm not going to go through the checks for these, but you should definitely check them out on your own by taking that negative 3, plugging it back in, and making sure you don't get any extraneous solutions, things that don't work. You should also do that with the 729 and the next couple, but I want to save time on our video here, so I'm not going to go through the checks of everything. 38. Our radicals, there's 2 of them this time, so we want to make sure that they're by themselves. There's nothing with either of those, so we want to square both sides. The square root and the square cancel, and we end up with 26 minus 2n. On the other side, the square root and the square cancel, and you end up with 2n minus 6. A bit of a more complicated equation, but we can do it. We're going to add 2n to start, and we'll have 26 equals 4n minus 6. Add our 6 over, and we'll have 32 equals 4n. Divide by 4, and we'll end up with n equals 8. Again, you should plug that back in, make sure that it's not extraneous. And number 40, the last equation that they want you to solve. You need to square both sides. So we're going to start by squaring this, and then we're going to square this. So we'll have x squared equals the square and the square root cancel. So you have 12 minus x. Now, a lot of people will get confused here and say, I don't know what to do, Mr. Sheehan. And I would say you have a square there, so you need to get it to equal 0. So we're going to add our x, add our x. We cannot combine those because they are not like terms. So you'll have x squared plus x equals 12. And then you want to subtract 12. Subtract 12. You can't combine anything there. So you end up with x squared plus x minus 12 equals 0. We got to factor that. Well, x squared minus x squared plus x minus 12. We're going to have x's in the front. We need factors of 12, 1 and 12, 2 and 6, 3 and 4, that get us to a positive 1. Well, the only set that does that is 3 and 4. And we want a positive 1, so it will be a positive 4 and a negative 3. So we just factor that, then we want a t-bar. X minus 3 equals 0. X plus 4 equals 0. So we'll end up with x equals 3 and x equals negative 4. You should check both of those back in the original equation to make sure you don't get any extraneous solutions. But we're going to move on to number 42. Moving into some imaginary numbers here. These are simple ones. This is adding and subtracting. So we just need to make sure that we don't have any minuses here because that would have to distribute into the parentheses. We don't, so this will be negative 2 minus 3i plus 6i plus 5i. Well, we can take that negative 3 plus 6 plus 5 and combine those all together. So we'll have negative 2, and negative 3 plus 6 is 3, plus 5 is 8. So plus 8i. And that is our final answer. 44 is multiplying. So we have negative I times negative 5i. Well, negative times a negative is going to be a positive. 5, I times I is I squared. This is where it gets a little tricky because you have to remember that I squared is negative 1. Remember the 4 that you have to remember. I to the 0 is 1. I to the first is just I squared is negative 1. And I to the third is negative I. So in this case, we have an I squared. So that's going to be 5 times negative 1, which is just negative 5. Now that looks a lot simpler than what we started with, right? Right. Moving on to 46. Even more complicated here. We want to start by multiplying these first two. So I times 6i is 6i squared. Well, we know that I squared is negative 1, so that's 6 times negative 1. Or negative 6. I'm just going to bring this next part all the way down here. 8 minus 2i. Now we need to distribute. Negative 6 times 8 is negative 48. Negative 6 times negative 2i is positive 12i, which is our final answer. So we multiply the first two, distribute what we get into the second part there, and we're good to go. 48 is a division problem. This is very similar to rationalizing the denominator. We have a monomial down here. So that's one term. All you have to do is multiply through by I in that case. So multiply by I on the top, multiply by I on the bottom. That means on the top, you're going to have an 8i. On the bottom, you're going to have a negative I squared, because I times I is I squared. So the top is pretty much done. 8i over I squared is negative 1, so that's negative 1, or just positive 1, which leaves us with just an 8i. This is actually 8i over 1, which brings us back to here. You want to make sure you're as simple as possible, so you should never have a 1 in the denominator. Just write it as 8i with nothing underneath it. 50, getting a little more complex. Again, just a monomial on the bottom there. So we want to multiply through on top and bottom by I and by I. So on the top, we're going to have 10 plus, 10i, because we're distributing the I up here, plus 4i squared. On the bottom, we're going to have 8i squared. So we're going to replace those with negative 1s. So we'll have 10i plus 4 times negative 1 over 8 times negative 1. Or 10i minus 4 over negative 8. Now if you see in there, 10, 4, and 8 can all be divided by 2, which would leave us with a 5, a 2, and a 4. So the very final answer here should be 5i minus 2 over negative 4. If you had decided to, you could have come up with a different answer, which would be negative 5 plus negative 5i plus 2 over positive 4, if you had taken a negative out instead. That is your final answer there. And the last one. Oh, sorry, second to last one. This problem has a binomial on the bottom. It has a plus in the middle. So that means you have to multiply through by the conjugate, which is negative 6 minus 3i. Negative 6 minus 3i. When you do that, the top we're going to distribute that 3. So we'll end up with negative 18 minus 9i over, on the bottom we have to FOIL. Negative 6 times negative 6 is positive 36. Negative 6 times negative 3i is positive 18i. Positive 3i times negative 6 is negative 18i. And positive 3i times negative 3i is negative 9i squared. Our outers and inners are going to cancel there. We know that I squared is really a negative 1. So now we have negative 18 minus 9i over 36 plus 9, because that negative 9 times negative 1 gives us a positive 9. So when we add the bottom, we have negative 18 minus 9i over 36 plus 9 is 45. Now I know you're all super smart, and immediately you see that 9 goes into all of those. So this turns into a 2, this turns into a 1, and this on the bottom turns into a 5. And we now have negative 2 minus I over 5 is our final answer. Getting close to the end. Number 54. Again, the denominator here has a minus in the middle. It's a binomial, so we need to multiply by the conjugate, which is going to be negative 3 plus 9i. Negative 3 plus 9i. And I know you're all hating me by this point because now you have to FOIL twice. You're going to have to FOIL on the top, first outers, inners last, and you're going to have to FOIL on the bottom. So for the top, 9 times negative 3 is negative 27. 9 times positive 9i is plus 81i. 9i times negative 3 is negative 27i. And 9i times 9i is 81i squared. Positive. The denominator Negative 3 times negative 3 is positive 9. Negative 3 times positive 9i is negative 27i squared. Negative 9i times negative 3 is positive 27i. I'm sorry, there shouldn't have been a squared over here. That should just be I. And on the end, negative 9i times positive 9i is negative 81i squared. Now, I know you're all saying, Mr. Sheehan, that's a really long problem. It is a lot of work, but it's not really super difficult work. On the top, we want to combine some stuff. Let's start by saying that this I squared is negative 1. We can do that on the bottom also, that I squared is negative 1. And in the middle here, our positive 81i and our negative 27i can go together. So we're going to have negative 27 plus 81 minus 27 gives us 54 with an I. And on the end, we're going to have minus 81, because 81 times negative 1 is negative 81. The denominator. Our inners and outers will cancel, so we'll just have our 9. Negative 81 times negative 1 is plus 81. So the top, we have two things that can go together. We have negative 27 and negative 81, which gives us a negative 108 plus 54i over 9 plus 81 is 90. Being the smart cats that you are, you know that 9 goes into every single one of those. So we're going to end up with a 12 here, a 6 here, and a 10 here. So we have negative 12 plus 6i over 10. And again, being the super smart cats that you are, you notice that 2 goes into 12, 6, and 10. So we're going to have a 6, a 3, and a 5. And I'm running out of room here, so I'm going to have to work my way up now. So our very final answer should be negative 6 plus 3i over 5. Again, a long problem with a lot of work, but none of it's really super difficult work. It's not like that other crazy nonsense we were doing in the first chapter with all that factoring and foiling and all that. This is just 2 foiling problems, which you're all really good at. Break it down step by step, and you'll be fine. You can do any one of those problems you're given. Last couple problems here. When you are graphing imaginary numbers, it is no longer the x and y axis. Remember, this is now the A, and this is the B, because your complex numbers are in the form A plus BI. So this first problem here, your A is 3, your B, the number in front of that I, is a 1. So that means you're going to go from the origin, you're going to go forward 3, 1, 2, 3, and you're going to go up 1. So your final point will be right there. I probably shouldn't put a dot there on the origin. So starting at the origin, you go over 1, 2, 3, and go up 1. So this is number 56. The second one, your A is negative 4, your B is negative 2. So from the origin, you're going to go backwards 1, 2, 3, 4, and down 2. So your final point will be right here. And you could draw arrows here if you want, but that is number 58. You can either put a point or you can draw what's called a vector. Number 60 here, your A is positive 2, and your B is negative 4. So from the origin, you're going to go 1, 2 forward, and then you're going to go down 1, 2, 3, 4. So your final point ends up here. You can draw a vector to it if you like, and that is number 60. And the final problem, A is negative 3, B is negative 2. So we're going to go backwards 1, 2, 3, and we're going to go down 2. It's very close to the previous one. You can draw your vector, and that is number 62. If you have questions on any of those problems, come prepared with them. You'll be taking your test. Have a wonderful rest of your weekend.